In math lesson 7.5, we are going to do a triangle hierarchy. You will need to start off with your whiteboard marker, and we'll move into our journal in just a few moments. Would you go ahead and just write what power they multiplied and divided by in each one of these to come up with the answer? So go ahead and number 1 and number 2. You don't have to write down the whole thing, but write down what did they divide by in number 1 and what did they multiply by in number 2. Remember, when you're multiplying, the decimal point moves to the right. If you are dividing, the number gets smaller and it moves to the left. So for number 1, remember the decimal point when it's a whole number is like saying 45 and 0 hundredths or 0 tenths. So to move it one place to the left, it would be 10 to the first power. The decimal point moved 2 places. Even though you don't see it, it's like saying 312 and 0 tenths. It moved 2 places to the right. 10 times 2 to the second. 10 to the second power. All right, number 1 and number 2. Remember, they are dividing. The number is getting smaller, and the decimal point moved to the right. So what did they divide by? 10 to the what power? 10 to the what power? Go ahead and fill that in. So number 1, that decimal point moved 2 places, and a 0 had to be added. So 10 to the second power. The decimal point would have been right here, 97 and 0 tenths. It moved 2 places to the left, divided by 10 to the second power. All right, 2 more. Now you have to tell if they multiplied or divided and by what power. So you have 2 things to fill in. Remember, you're multiplying if the number gets larger and the decimal point moved to the right. You're dividing and moving the decimal point to the left if the number is getting smaller. So go ahead and fill in number 1 and number 2. Pause the video as needed. So number 1, the decimal point moved 1, 2, 3 places. So they multiply because the number got larger, and they multiplied by 10 to the third power. 13 hundredths. It got smaller, and it was right here, so it moved 1, 2, 3 places to the left, so 10 to the third power. I want you to think about triangles for a minute. What properties do all triangles share? In other words, if you think of different triangles, what do they all have in common? Would you write down on your whiteboard everything that you could think of that triangles have in common? Go ahead and pause the video. We know they are 3-sided. We know they have 3 angles. And maybe you know that all of the angles add up to a total of 180 degrees, no matter what type of triangle. Does anyone remember what we call triangles with at least 2 sides of equal length? When we use what we call tick marks, they indicate 1 tick mark would mean that these 2 sides are equal. If it has 2 tick marks, like this, they mean that those 2 would be the same length. So if it has If it has two equal sides, it is called an isosceles. Means it has two equal sides. If it has three equal sides, does anyone remember what it is called? Think about this word. It is called an equilateral triangle. What happens if no sides are equal? What do we call it? You may have heard these just maybe a couple of times. It is called a scalene. A scalene. And those are just things that you have to remember. Equilateral triangle is a little bit easier because it does have the word equal in it. All right. I want you to open your math journal to lesson 7.5, and it is on page 246. Page 246. You're going to have to do some drawing. I thought I included this in your packet, your white packet that's stapled together, but somehow I sometimes miss the back side of it. So we're going to do a little bit of drawing today. I want you to take a look at the triangles on the right-hand side. These are all different types of triangles. So on the left, in other words, on page 246, you're going to write the categories and subcategories from the triangle hierarchy you created in class. Use the hierarchy to classify your triangle cards. So we'll do that together. When you're finished, glue or tape the cards in place. And we're just going to say draw. You're going to draw as best you can to show how we would group these triangles. One way I could classify them is by just what we talked about here in this types of triangles. If I look at their attributes, attributes would be what we would call a quality or trait belonging to an object. And so we can isolate those that are two equal sides, three equal sides, or no equal sides. So you can see these tick marks. So I'm going to go ahead and classify them by isosceles, by equilateral, and by attributes where they are scalene and don't have any equal sides. Okay, now I can tell if it has equal sides based on the tick marks. So I'm going to start with, and you're going to draw them, so go ahead and write the three categories, the three attributes, isosceles, equilateral, and scalene. All right, now I'm going to take this one right here. This one is equilateral. This one is equilateral. This one is equilateral. Do you see any others that have tick marks? It would indicate the sides are the same length or have the same property. Okay, let's go to the next one. Isosceles has sides that are the same length, two of them. So this one right here, notice it has a right, so it's also a right triangle. Anytime you have one angle that's a right angle, the whole triangle can also be referred to as a right triangle. This one right here has two sides that are the same length, as does this one here. Sorry, it would have been much better if I just would have photocopied this for you. Now the other ones don't have any marks, or it will indicate that this one has one tick mark, another one has 2 and 3. That is scalene. So I'm going to start with that and draw that. 1, 2, means they are all different lengths. As is this one here. Now I can draw the rest of these. I'm not seeing that any of the sides of the lengths are the same. We know this is a right triangle. So this could also fall into another category. The rest of these are all scalene. So at the top, I could say these are all triangles, right? They all fall under the category of triangles. And within that category of triangles, we have triangles that are isosceles. Triangles that are equilateral. So they can fall within subcategories as well. Move please on to page 247. Page 247. It says use the triangle hierarchy on page 246 to answer the questions. Name a category shown on the hierarchy, then name a subcategory of that. So we said a category was triangles. So this is my category, and a subcategory coming with underneath the triangles would be isosceles. Please draw an isosceles triangle. Remember, we want two sides to appear the same length, and just to prove that they are the same length, we're going to put those marks on it. B, draw a triangle that is not an isosceles triangle. So we have to have sides that look different lengths, and if I wanted to make sure, I would go ahead and show they have 3 different lengths. Draw an equilateral triangle. Remember, the word equal means that all sides are the same length. Is your equilateral triangle also an isosceles? You know what? It is, because equilateral triangles are a subcategory of isosceles, because isosceles has two equal sides. Equilateral has two plus one more. So all equilateral triangles are also isosceles. Oops. Please make sure that you pause the video if you need a little bit more time. Continuing down the page, number 4. In each statement below, replace the underlined category with a different category from the triangle hierarchy so that the new statement is still true. So all triangles have 3 sides and 3 angles. Well, I'm going to go ahead and cross that off and just say that all isosceles have 3 sides and 3 angles. That is true. B, all isosceles triangles have at least 2 sides that are the same length. I'm going to cross that off and say all equilateral right? Because an equilateral has 3, but it does have at least 2. All isosceles have a line of symmetry. All equilateral triangles have a line of symmetry. Could put the word or the symbol for triangle there. All right, we won't worry about number 5. All right, continue your work for math today.